morning, viewers. This is Kasturi Day. Today I'm starting with the ICSE specimen questions of the chapter Motion in One Dimension. So I will tell you these, discuss these specimen questions with you all today. So before I start, I would request you to please to subscribe my channel and also ring the notification bell so that you can get the notification as soon as the video is uploaded. And if you are liking the video, press the like button, share with your friends so that they can also get these videos. And please don't forget to meditate before you start your day. So let us practice for 1 minute meditation, and then we will start with the discussion. So for meditation, let us concentrate on the point of light, which is coming to you, which is body. Lot of energy. Body, each and every part of your body is getting energized. This light. The happiest person in the body. Enthusiastic. The most enthusiastic person in the world. Start with the discussion today. So, first question which we will discuss today is give an example of motion in which average speed is not zero, but the average velocity is zero. Average velocity is zero, but speed is not. Average speed is not zero. So, for that example, this is the answer for the first question. That is, the car is moving with an average speed and it returns to its original position. Moving with an average speed, it is coming back to its original position. Here, a car has an average speed which covers the distance of r. The distance is r in time t. It's covering while coming back to its original position. It covers again the same distance, that is r again, same time that's t. So the total speed of the car is s, which is equal to going from the original position to the final position is r, and again from that final position coming back to its original position, that is also r. So distance r plus r in the time t. Okay. So that consider as t as the time. Okay. So 2r by t meter per second. Total distance, total speed, okay. The velocity is given by the total displacement covered in the given time. As the car is returning to its original position, then r is taken to be as a negative sign as displacement takes into account both magnitude and direction. So it's going from its original position to the final position, so plus r, okay, one direction. Coming back in the opposite direction. Okay, so the direction is reversed, but the distance is the same. So displacement will be same. Okay, that is r, but with a negative sign. Okay, because it is coming back in the same place with in the opposite direction. So it will be minus r. Okay, so r plus minus r, that means r minus r. So displacement will be 0, and the time is t. Time taken is the same, that is t. But so as the displacement is 0 by t, that becomes 0 meter per second. So velocity will be 0, whereas speed will be 2r by t meter per second. So average speed is not 0, but the average velocity is 0. Clear? So this is the example of that question, that is having an average speed but average velocity is 0. So next question, we move on. question is draw a displacement time graph for a boy who is going to school with uniform velocity. Displacement time graph for a boy who is going to school with uniform velocity. So what will be that? See, this is the graph which has a displacement on the y-axis and time is on the x-axis. Okay, for a boy who is going to a school with uniform velocity, this velocity is uniform. That is, displacement is changing. The change in displacement, that is uniformly, it's changing with respect to time. Okay, as the boy is going to school from home and his initial velocity is zero, initial velocity will be zero, and is going with uniform velocity. Therefore, the slope of the displacement time graph will be a straight line which is passing through zero, okay, to the origin. So this is the graph which represents what? The displacement and time, displacement and time of a boy who is going to school with a uniform velocity. Clear? So next we move on the third question, that is define uniform acceleration and give an example of a body having this motion. Uniform acceleration is one when a body moves along a straight line and its velocity increases. Okay, when a body is moving in a straight line, it's moving in a straight line and its velocity is equal, I mean, it's increasing by equal amounts in equal intervals of time. That is, every 2 hours, it's increasing by, say, 2 meters per second. So the change in velocity is equal in terms of equal intervals of time. Okay, in respect to equal intervals of time, then the motion is known as uniform acceleration. Okay. For example, motion of a freely falling body. If a body is falling freely from the top to ground, it's reaching the ground, then it has a uniform acceleration. Okay, because its time, its changing in velocity is with the uniformly is changing in respect to equal intervals of time. Now, if I travel to Mumbai, from Mumbai to Pune by 150 kilometers in 2.5 hours via express highway and return to Mumbai via the old highway in 3.5 hours. So, person is traveling from Mumbai to Pune, that is 150 kilometers. Via the express highway, it takes 2.5 kilometers, 2.5 hours. But when he's returning back, he is coming back via the old highway, which is 180 kilometers, 30 kilometers more than the express highway, and that takes a time of 3.5 hours. So calculate the average velocity during the entire journey. How do we calculate? See, the average speed is for an object which is moving with variable speed, its average speed is the total distance traveled by the object divided by the total time taken to cover the distance. So what is average speed? Total distance by total time taken. Then, so that will be from Mumbai to Pune, it's 150 kilometers and time taken here is 2.5 hours. And from Pune to Mumbai, it's 180 kilometers and time taken is 3.5 kilometers, 5 hours. So what will be the average speed? Average velocity will be what? Average velocity will be 150 plus 180, S1 plus S2. S1 is the first distance from Mumbai to Pune and S2 is from Pune to Mumbai, return journey. So that will be S1 plus S2, that is 150 plus 180, and time taken for first when he is going through express highway, that was 2.5 hours, and when it's returning, and that is to 3.5 hours, that's time T2. Okay, so the time is also added, that is 2.5 plus 3.5, that becomes 150 plus 180, and divided by 2.5 plus 3.5, that gives you 55 kilometers per hour. Average velocity is 55 kilometers per hour. Okay, so this is the average speed or average velocity. Average speed, let's say, because the question is average speed only. So we are finding it average velocity, average speed, that is 55 kilometers per hour. Okay. Now we are moving on to the next question, that is the fifth question. A car is traveling with uniform velocity of 20 meters per second in 5 hours. The brakes are then applied for 20 meters per second. For 5 seconds, it's moving on with uniform velocity of 20 meters per second. Then brakes are applied. Then what happens? The car is uniformly retarded. First there was acceleration and now there is retardation. It comes to rest after 8 seconds. Okay. Now finally, find the distance traveled in 5 seconds. The distance traveled after the brakes are applied, the total distance traveled, and what is the acceleration during the first 5 seconds and last 8 seconds. Okay, so let's move on to the answer of this question. So first, let us see the graph. See, its first initial velocity was 20 meters per second. So velocity is on the y-axis and time is on the x-axis. So for first 5 seconds, it is moving with 20 meters per second. Okay. So initial velocity is 20 meters per second. That will be a straight line till 5 meters per second, 5 seconds. Okay. Then brakes are applied. And now the car is retarding. After 8 seconds, it will stop. After 8 seconds, till from 5 seconds to 8 seconds when it is moving, it is it is retarding. The car is slowing down, and then after 8 seconds, it stops. Okay. Now let us see. Initial velocity, that is u, is 20 meters per second. T1 first time, that is 5 seconds, and T2 is 8 seconds. Now graph image we have seen. And next question is distance traveled in the first 5 seconds. So area of ABDE, this squaring. Okay. So what is it? 20 meters per second, and here it is 5 seconds. So 20 into 5, that's equal to 100 meters. Will be the distance covered by the car in first 5 seconds. Okay. Next, after the brakes applied, how much distance it has covered? Okay. Now, so we get a triangle in that case. So for making the if we find the area, that will give the distance after the brakes are applied. So that will be half into base into height. So half into base is what? From 5 to after we need to count 8 seconds after 5. So 1, 2, that is 5, that is 6, 7, 8, 9, 10, 11, 12, 13. Okay. So till 13. That means it will be 8 seconds. So that this will be 8 seconds base, and this one height will be 20 meters per second. So that will be equal to half into 8 into 20. That will be, the distance will be 80 meters. Okay. Next, the total distance which is traveled, total distance will be the addition of both the areas, that is of the square and also the triangle. Okay, if we add them up, we will get the total area, and that will be the total distance traveled. Okay, so area of ABDE plus area of BCD, that is 100 plus 80, that is 180 meters. Now, when acceleration during the first 5 seconds, that will be 0 because it is moving with uniform velocity. So there's no change in velocity, and therefore the acceleration will be 0. Now in the last 8 seconds, okay, that time final velocity will be 0 because it is coming to rest, and initial velocity will be 20 meters per second because it was moving on 20 meters per second, velocity of 20 meters per second for 5 seconds, and then it is being retarded. So first initial velocity which will be 20 meters per second, and final velocity will be 0, and time will be 8 seconds. So let us find out from the formula. V is equal to U plus 80. So V, we know it's 0 meter per second, and initial velocity, that is U, is 20, and plus A into T. We need to find out the A, that is acceleration, into the time, that is T, that is 8 seconds. Okay. So that will give us what? A is equal to minus 20 by 8, that will be equal to minus 2.5 meter per second square, that is slope of the line BC. The slope of the line BC, that will give us the acceleration or negative acceleration or retardation of the car during the last 8 seconds. Okay. Next, we move on to the sixth question. Draw a diagram to illustrate the motion of a body whose speed remains constant but the velocity continuously changes. Okay. And then we come to some variable lines. So first we move on to the first part. The motion of a body in a circular path with uniform speed. Okay. When a body is moving in a circular path, okay, with uniform speed, has a variable velocity because velocity is continuously changing as it is moving in a circular path. Okay. And the direction of the motion is also changing. Okay. The direction of the motion of the body continuously changes over time. That's why velocity changes, variable velocity. Okay. That speed is uniform. Okay. So this is the example. Next, we move on to some fill in the blanks, which is the part 6b. Okay, the acceleration of the body is uniform in uniform motion is equal to c. Uniform motion when it is there, therefore the acceleration becomes 0 because its velocity does not change. Okay. Now a body is said to have dash when its final velocity is less than the initial velocity. When its final velocity is less than the initial velocity, then the body is said to have negative acceleration because final velocity is 0, okay, less than the initial velocity. The initial velocity is more and final velocity is less, then it has a negative acceleration or retardation. Okay. Now initial velocity u is equal to what? It's 0. That means rest. Okay. Then final velocity will be what if the time is 5 seconds? Body initially at rest, that means its initial velocity is 0, while going down in an inclined plane, that is, it's coming down. So it has an acceleration of 2 centimeters per second. Acceleration is 2 centimeters per second. It's initially the body is at 0. When what will be its velocity 5 seconds after the start? When it started with a 0 velocity and it's coming down after 5 seconds with an acceleration of 2 centimeters per second square. So V is equal to U plus AT. Okay. Now we know that its initial velocity is 0. Okay. And acceleration is 2 meters per second. Sorry. Yes. The acceleration is 2 meters per second and time is 5 seconds. So that will be equal to 10 meters per second with its final velocity. Okay. Next, we move on to the of this question 6. That is the displacement time graph of a particle is, as shown in the figure. Is its motion uniform or non-uniform? So this is the displacement time graph. This picture, this is like a parabola. Okay. Now, from this, we need to identify whether its motion is uniform or non-uniform. The motion is non-uniform. Why it is so? Because it's a parabolic curve and it is not a straight line and it should be in uniform motion. If it is in uniform motion, then it should be a straight line which should pass through the origin. But here it's becoming a parabolic curve, which indicates that its motion is particle motion is non-uniform. Okay. Next, we move on to the part E of this question. That is, a train moving with a velocity of 20 meters per second comes to rest in 5 seconds when the brakes are applied, and what is its retardation? Okay. So now given at u is equal to 20, that is initial is 20 meter per second. Velocity, final velocity is 0 and t is 5 seconds, and acceleration we don't know, we need to find out. So that will be v is equal to u plus at. Okay, therefore it will be v plus at, that is final velocity we know that's 0 and initial is 20, and acceleration we need to find out because 5 seconds is the time. So that will give us minus 4 meter per second. So retardation is 4 meter per second. Okay. So let us stop here. 3-4 more questions are left. We will discuss in my next video. In the next video, I discuss it. Okay, and finish this chapter, and we will move on to the question answers of this chapter. Other questions besides these ICSE specimen questions. We will discuss that, and after that, we will move on to the biology chapter. So, till then, please go through this. If you have any doubt, please write in the comment box. You can also refer to my email ID, kasturi74@gmail.com. Okay, and if you are a new subscriber, you should continue with my, should remain with me, tuned with me, and so that you can get the benefit of these discussions. Okay, and if you are a new viewer, please to subscribe my channel and ring the notification bell to get the notification as soon as new videos are uploaded. If you are liking the video, press the like button, share with your friends, and so that they can also be benefited from these videos. And also do meditate before starting your day, and whatever you do in the day, also in the middle, also you can do the meditation. That will help you a lot, I'd say. It will increase your interest, it will make you feel happy, and you can enjoy the subject which you are taking. Okay, so thank you for watching, and have a